So in my opinion, one of the most topics that is used the most in Chem 30 from Chem 20 is net ionic equations. So you do spend a bit of time on it, but not that much considering that it's so important for Chem 30. It's something we want to be really good at because it comes up time and time again. So when you're looking at net ionic equations, solubility does come into play. We want to be able to use this chart. Usually this chart is if you take an ionic compound, which is a solid, and you stick it in solution, what are you going to get? Aqueous or solid as a state. So to read this chart, you usually find your negative ion first, and then you would come down and find the positive ion. If it's, say, listed, then you go to the left, and if it's very soluble, it's going to have an aqueous state. If, say, it wasn't one of these two, instead it would fall under most, then you would come over here and say it's a solid state. So it just depends. So when we're looking at that, it definitely only involves ionic compounds, right? They're solid at room temperature. If you put it in water, will it dissociate? Will it form those ions or will it stay together? So it helps us predict. Now, that helps us, this chart, when we're predicting those net ionics. So if I want to write a balanced net ionic equation between the reaction of aqueous magnesium chloride and silver nitrate, then I start with the reaction like a balanced chemical equation. So let's start by writing that out. So you have magnesium chloride, so MgCl2. It's aqueous, so we don't need to check this chart because it says it in the question. I'm going to add on aqueous silver nitrate. And my products, double replacement reaction, I will have magnesium come together with nitrate. And there's a 2 here. And silver comes together with chlorine. Now I jumped ahead here, see? And wrote this was aqueous, but to show how I got that, I would look at my chart, I'd find the NO3 ion, and then come down to find magnesium. I don't see it in here, so it'd be under most, and then I look over here, it's very soluble. For silver chloride, chlorine is here, come down to find silver is here, moving over, meaning this one is a solid. Now I still do need to balance it, and to balance, I believe I just need to add in a couple of 2s. And now it's balanced. Okay, so that's your first step, balanced chemical equation. The second step is to break apart what you can. So you can break apart ionic compounds in solution. So is it ionic and is it an aqueous state? Solids, you can't. That's going to stay together. So if I write this out, I would have this breaking into its ions, so Mg2 positive, plus, there's a 2 here, so 2 chlorine ions, and this state stays aqueous. Then I move on to the next one. This 2 out front means you have 2 of each ion. So 2 Ag positive plus 2 NO3 negative. Moving on to products, I have Mg2 positive plus that 2 means there's 2 of the NO3 ion. And then again, this last part, because it's a solid, you just write it down exactly how you see it. Okay, so now this next step, after my complete balance equation, brings me to my total ionic equation. So showing all the ions. But I don't want the total, I want the net. So that to get there, you just cross off whatever you see that's completely identical on both sides. Once you have that, then you can write down what you have left over, and this shows you within this reaction exactly what is reacting. So this last part is my net ionic, so that would be my answer, and my spectators would be magnesium 2 positive and NO3 negative. There would be 2 of them, ions that are present but have nothing to do with the reaction. As always, I hope you found this helpful. If you did, please subscribe. And if there's any other thing I can help you with, just leave me a comment and I'd be more than happy to. Thanks for watching.